So our y hat is a predicted value for some actual population parameter. And as we've seen from our scatter plots, it may or may not be accurate. So what we can do is create a confidence interval for it, and we call that a prediction interval. So for example, from our data, let's say I have an 8-year-old daughter, and I want to know, like, well, what kind of reading level can I expect? So take a look at this graph that we still have here, okay? I don't know where my 8-year-old is. Oh, we'll just say here, okay? So this line is going to give us a predicted value that I can expect my daughter would have a reading level of that. But we can see from the data points, it might be above or below that. So what we're going to do is we're going to create an interval around this to say, okay, how much above or below might she be from that predicted value? Okay, so that's what this is looking at. The calculation for the margin of error is given by this. Okay, we need a critical value for t. We need that SE that we just calculated, and then some other things. So I'll show you how to get those. So that's our equation. Degrees of freedom is n minus 2. You'll need that when you're looking up that critical value of t. And then what we'll do is we'll take that predicted value. So remember, my 8-year-old daughter, we predict that she has a certain score, and we'll add or subtract that margin of error to get an interval that I can be, whatever, 95% confident or whatever, that her reading level is going to fall in that region, okay? So we're going to actually do this one, construct a 95% prediction interval for the reading level of a child who's 8 years old using this data. This is the same data we've been working with, okay? So hopefully it's still in your calculator. Now, the bad news is the calculator doesn't do this directly, okay? You are going to have to slog through this formula a little bit, okay? Let me walk you through it. So we found our equation. Y hat is negative 3.811 plus 0.865x. Remember, we store that in y1, so it's right here, minus the rounded one. And then we're going to plug in an 8-year-old. So at x equals 8, we're just going to plug that in. We get y hat is, I plugged this in somewhere else and I wrote it down, 3.109. Okay, so my pretend 8-year-old daughter, we are going to predict that she has a reading level of 3.109. Now, there's some margin of error. She might be a little bit above or below that, and that would be totally natural to expect. So we're going to take that and we're going to add and subtract this margin of error. So now we need to use that margin of error formula that we had. Okay. We can get some of these values from the calculator, so it's not quite so obnoxious. So let me start showing you where all of this comes from. This critical value of t, you're going to look that up on your t table, alpha over 2. Remember, alpha is your 0.05. So you're looking that up in the table. And the degrees of freedom is n minus 1. So when I did that, I got 2.306. Remember, that table is in the back of your book, or it's on that yellow formula sheet that you have. SE, we calculated that in the last video. That was 0.4174. All right, and then we have square root. That was terrible, whatever. 1 plus, n is just the number in our sample, so that's 10. Plus 10. Okay. XO, that's what we're talking about. That's our 8-year-old, okay? So XO is going to be our 8-year-old. And then X bar, that is going to be the mean. So this is where we're going to start looking to our calculator for help, okay? All the rest of these values are going to come from our calculator. So go back to stat, calculate, and we want to calculate 2 variable stats, okay? Now, your menu might look a little different than mine because you have a newer calculator, but our data, all of our original data is L1 and L2. So that's what we want to calculate our stats on. And it's going to do that for us, okay? And it's got a bunch of pieces in here that we need. So X bar, you see, is 10.5. So we'll come over here and write that in. So 10.5. And we need to square that. And then our denominator, we have 10. And then do you see here we have the sum of x's squared? That's right here. The sum of x's squared is 1185. Okay, so that's just going to come straight from the calculator. Minus, and then this is the sum of all the x's, and then we're squaring that. The sum of all the x's is right here, 105. So we're going to do minus 105, and that thing squared. Okay, so those are all the pieces. That's where they all come from. Now, the trick is getting this all in your calculator. Okay, I recommend you start with this fractions. Put parentheses around the entire numerator and the entire denominator here. So do this part and then add 1/10 and 1. And then once you have that answer, then take the square root of it and then multiply it by these two things. Okay, I know that's a challenging thing to get in your calculator. But we get 1.043793 when you do all of that. All right, then what we're going to do is we want to take that y hat that we calculated and we want to add and subtract that error. Okay, so remember we said we expect my 8-year-old daughter, who's imaginary, to have a reading level of 3.109, and we're going to add and subtract this number. Okay, and when we do that, first when I subtract it, I get 2.065. And then when I take that number and add it, I get 4.153. Okay. So that is our prediction interval. We should also interpret this just like we always interpret stuff. Let's see. What we might say is for an 8-year-old, that's important. We need to say who we're talking about because for a 10-year-old, this would be a totally different equation. So for an 8-year-old, we are 95% confident that she will have a reading level between 2.065 and 4.153.